Today we're going to look at section 5.3c. We are continuing to solve polynomial equations by factoring. Our new technique today is to factor what we call a sum or difference of cubes. All right, so we're going to start with the factoring technique and then we'll add in the actual solving with that technique. So we've talked about differences of squares before, where you have a perfect square like x squared minus another perfect square like 16. Okay, that's a difference of squares. When we're talking about sum and difference of cubes, it just means that the two terms in my polynomial are perfect cubes. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. You can continue that if you want. So we're looking for perfect cubes today instead of perfect squares. The pattern is the same both for a sum, where we're adding, and a difference. Okay? If you remember one of them, you can figure out the other one. So we have an a cubed plus b cubed. It's going to factor into the roots. So we take the cube root of a cubed, which is just a. We take the cube root of b cubed, which is b. And we use the same sign that we have to start with. So if we have a plus sign here, we're going to have a plus sign here. So notice with the subtraction one below here, it was a cubed minus b cubed. So we're going to have a minus b. Then the second factor is a trinomial. The first term is the square of our first number here. So we had an a here. We're going to have the square of it there. We have a b. The last term is going to be the square of that. And the middle piece is just the product of the two, so a times b. And notice that the sign we have here is always going to be opposite what we started with. Okay, always opposite. The last sign is always going to be positive. Anytime you square a number, you get a positive answer out. Okay? So, same thing with the a cubed minus b cubed. We're going to have the first term squared, so a squared. We're going to do the product of a and b, and we're going to have b squared. And the first sign is plus because it's the opposite of what we started with, and the last sign is always plus. All right, let's try a couple. So the first step is to find the root. If you take x cubed and cube root it, you just get an x. Okay? If you take 27 and cube root that, you get a 3. So my roots are an x and a 3. The first sign is always going to match what I started with. So since I had a plus here, I'm going to have a plus there. Then we build the trinomial. So we take our first number, our x, and square it. We multiply them together. X times 3 is 3x. We want the opposite sign, so it'll be negative. And then we square the 3. Okay? All right. Go ahead and figure out what is the root of x cubed and what is the cube root of 125. We've done this one already. The cube root of x cubed is just an x. The cube root of 125, if we look here, we see that 5 cubed is 125, so the cube root of 125 would be a 5. Our sign was a minus, so we're going to bring that down. That is the first of my two factors. Then I need the trinomial part, the 3-termed piece. The x, my first term here, gets squared. I do the product, 5 times x, and I change the sign. And then I do the square of the 5 to get a positive 25. All right. Now for this next one, notice that there's an 8x cubed, but we can cube root 8x cubed. It's just the cube root of 8 and the cube root of x cubed. So the cube root of 8 is 2, the cube root of x cubed is x. We're going to have a 2x. The cube root of 27 is 3, and we keep the sign that we started with. So that's the first part. Now I'm going to build the trinomial. I take the first term, 2x, and I square it. So 2x times 2x is 4x squared. I take the product, 2x times 3, and I get 6x, and I change the sign, so instead of it being negative, it's going to be positive. And then I square the negative 3. Negative 3 times negative 3 is positive 9. All right, I'd like you guys to pause the video and try this next one. 125x cubed plus 64. Turn the video back on when you are ready. All right, cube rooting each of these. The 125 becomes a 5, the x cubed becomes an x. The 64, its cube root is 4. And now we're going to build our trinomial off of that. So we take the first term, 5x, and we square it. 5x times 5x is 25x squared. We do the product. 5x times 4 is 20x, and we change the sign to a negative. And then we square the 4. 4 times 4 is 16. So you should have 5x plus 4 as one of your factors, and 25x squared minus 20x plus 16 as your other one. All right, our last example for strictly factoring it has an extra variable in there, but that's okay. We're going to follow the same pattern. 127 cube roots into a 3. The cube root of x cubed is an x. We keep the sign. The cube root of 64 is 4, and the cube root of y cubed would just be a y. And then again, we're going to build our trinomial from those numbers. So we square the first one. 3x times itself is 9x squared. We take the product. 3x times 4y would be 12xy. We change the sign. And then we square the last piece. 4y times 4y would be a 16y squared. And remember, that last one is always positive. So that's the technique of factoring the sum and difference of cubes. Now we're going to use it to help us solve some polynomials. We're going to factor based on our pattern. And then the linear piece is easy to solve. The quadratic piece, we have to use that quadratic formula to get. All right, we're always going to get imaginary solutions, so we should always have an I once we do that quadratic formula. All right, let's try one. We have x cubed plus 27. Now we factored this as our first example from the previous page. So x cubed plus 27. The cube root of that is an x. The cube root of 27 was a 3. Our trinomial part, remember we square the first term, change the sign and take the product, so 3 times x, and then square the 3. So when we solve this now, because there's a 0 on the end, we can actually solve it. It's equal to something. We want x plus 3 to be a 0, or we want x squared minus 3x plus 9 to be the 0. So the first one is easy. This is our linear factor. We just subtract 3 to the other side. So one of my answers is going to be negative 3. The other part is a quadratic. It's an x squared trinomial. So we're going to use that quadratic formula to solve this. So remember our quadratic formula. X equals the opposite of b plus minus the square root, b squared minus 4ac all of it divided by 2a. All right, so plugging those in. We want the opposite of negative 3, so positive 3, plus and minus the square root. Our b was negative 3, we have to square that, minus 4 times our a value, which is a 1, and our c value, which is a 9. And we're dividing the whole thing by 2 times our a value. So we have x equals 3 plus minus our whole piece under that square root, all divided by a 2. Underneath our square root, we have negative 3 squared, which is 9. We have 4 times 1 times 9 is 27. We're subtracting that. So we end up with 3 plus minus the square root of negative 18, all divided by 2. And then we break down that square root. So we have 3 plus minus all over a 2. 18, you can think of it as 9 times 2. So we get a 3 root 2. And because of the negative, we're going to get an I. So 3i root 2. So we are getting 3 answers. Our first one was this x equals negative 3. And our last two are x equals 3 plus minus 3i root 2, all divided by 2. I'm sorry, I see a mistake I have here. I was doing the subtraction in my head. 4 times 9 was 36, so this should be a 27. So split that into 9 times 3, we would get 3 root 3 instead of 3 root 2. I apologize for that. All right, our next example. We have 8x cubed minus 1 equals 0. We're going to factor that. It's a difference of 2 cubes. Our 8x cubed cube roots into 2x. The cube root of negative 1 is just negative 1. Then let's build our trinomial. We take our 2x and square it, so 4x squared. We take the product, 2x times 1 is 2x, and we change the sign. And then we square the negative 1, and it turns into a positive 1. Setting each of these now equal to 0. First one we're going to solve is just linear. We're going to add the 1 to the other side and then divide out our 2. So we get 1/2 as one of our answers. The second one, remember, is a quadratic, so we're going to go ahead and do the quadratic formula. X equals the opposite of b, so negative 2, plus minus square root, b squared, so 2 squared, minus 4 times 1, all over 2 times a. So x equals negative 2 plus minus our big square root. Our denominator here would be 2 times 4, which is 8. And then inside our square root, 2 squared is 4. We're subtracting 4 times 4 times 1, so we're subtracting 16. So x equals negative 2 plus minus the square root of negative 12, all divided by an 8. Simplifying that, we can think of 12 as 4 times 3. Square rooting that would give us 2 root 3. Because of the negative, we're going to have 2i root 3. Now, we could divide each of those pieces by 2. So the first chunk, if we divide those by 2, we get a negative 1 on top and a 4 on the bottom. And if we divide the second half of it by 2, we get just 1i root 3 and a 4 on the bottom. So negative 1 plus minus I root 3 all over 4. So that is my second and third solution. All right, a quick review. Let's look at what method seems to be appropriate for this. When we look at this first one, notice that there is an x common to all of the terms. So let's go ahead and factor out a GCF. We can take an x out of everything. That leaves me x squared plus 10x plus 24. Now, that's a quadratic, x squared. So we could always use the quadratic formula, but this one is factorable. So don't forget the techniques that we've had already in previous sections. We can factor this x squared plus 10x plus 24. We split up our x squared. We look for two numbers that multiply to be 24 and add up to 10. To multiply to be 24, we could do 1 times 24, 2 times 12, 3 times 8, and 4 times 6. To get a 10, we would need the 4 and 6. All right, so we just factored the whole thing, and now we can set each factor equal to 0. X plus 4 equals 0, we would just have to subtract the 4 over. And for the 6, we would subtract it over. So our solutions are 0, -4, and -6. For the last one, notice that we have 4 terms. This is the technique we talked about yesterday. When we had a 4-term polynomial, we did that grouping technique. So let's group the first 2 and the second 2. In the first 2, we can take a GCF of x squared out. We'd have an x plus 7 left. In the second half of this, we could factor out a GCF of 2, and that leaves an x plus 7 left. Then we factor out our common x plus 7, and the leftover pieces, the x squared and the 2, form the other factor. And then set them each equal to 0, like we did yesterday. So the first one I would solve simply by subtracting a 7. The second one I would solve by subtracting a 2, but because of that x squared, I need to square root both sides. So I end up with x equaling plus minus I from the negative, and then a root 2 is left. So as we add more and more techniques, you're going to have to pay attention to what technique works the best. It might be basic trinomial factoring, like we had here. It might be a grouping technique, like we had here, or it might be one of those difference or sum of cubes pattern that we learned today. All right, so for homework today, you are going to be working on worksheet 5.3c.